to just make a function here. Let's say my function is f of x equals 2 times x minus 3 squared plus 4. So we have to think of 3 different things, just like we did in class. We're going to think first of the parent function. We're going to think about the x stuff. And we're going to think about the y stuff. So first, the parent function is the main event that's happening. So here, think of your library of functions: squared, square root; cubed, cube root, absolute value. What we have here is squared. So the parent graph is y equals x squared. And that had a list of coordinates that went with them. -2 squared makes 4, -1 squared makes 1, 0 squared makes 0, 1 squared makes 1, and 2 squared makes 4. Now we're going to graph those in just a second, but let's get all of our information together. So now the second thing we're going to think about is the x stuff. So remember, the x stuff is what your parent function is applied to. So here our parent function is applied to x minus 3. So that squared is touching the entire thing, x minus 3. So our x stuff, x minus 3. Remember, this goes in solving order. So we're going to think about it equal to a number. And if we were going to solve for x, we would take that number and we would add 3 to it. So that's the math that's going to happen to our parent function. We're going to take these x's and we're going to add 3 to them. So that would give me, let's see, -2 plus 3 is 1. -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. And 2 plus 3 is 5. I'm just going to label this new. That one was parent. This one is new. So now you can think about what math happens there. If you take an x value, which is a left-right value, and you add 3 to it, what's going to happen to the picture? Well, that picture is going to move to the right 3 because we're adding 3 to get the new x's. Now the y stuff is everything that's happening outside of your parent function. So there's this 2 happening and there's this 4 happening. So those are going to be our 2 y things, a 2 and a 4. Now that 2, if you read the function 2 times this stuff, so 2 is timesing. And then plus 4, that was adding. So that's the exact move that I'm going to do to my y's. I'm going to take all these y's, I'm going to times them by 2, and then add 4. So 4 times 2 is 8, plus 4 is 9, 10, 11, 12. 1 times 2 is 2, plus 4 is 6. 0 times 2 is 0, plus 4 is 4. 1 times 2 is 2, plus 4 is 6. And 4 times 2 is 8, plus 4 is 12. So these are going to be our new coordinates to graph. So now what I'm going to do is I'm going to go ahead, I'm going to make my original graph here. So the original graph had -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Now, does this graph go up forever? Yeah, it sure does. But in order to see the movement and stretch, shrink, left, right, it's easier. It's easier to just look at those 5 points. So I have to graph 112. So this was 4. Let's do 8 and 12, just so it's easier to count. Everything's by 1. So 1, 2, 3, 4, 8, 12. All right. So 112, 112, 2, 6, 2, 6, 3, 4, 3, 4, 4, 6, and 5, 12. So let's connect those. We can talk about what happened. So we talked about how in the pink, the X stuff is going to move the picture to the right. 3, you can see that the black picture did move to the right. But now, what happened with the Y's? Well, when you times a Y value, Y's are your up and downs. So if you times a Y value by 2, it's going to be twice as tall. And then adding 4 is going to pick up the whole thing and move it up 4. And you can see that each one of these points corresponds to another point. For example, this point right here at -2, 4 got transformed to this point up here, 1, 12. Let's do another color. So this point right here, which was 1, 1, it moved to the right, sorry, -1, 1. It moved to the right 1, was twice as tall, and then went up 4, and, sorry, right 3. And it became this orange point. We could do this with all of the points. So 0, 0, moved right 3, got twice as tall, so it would still say 0 high, and then we moved up 4. This point here, 1, 1, moved to the right 3, got twice as tall, so now it's too tall, and then it moved up 4, so it became this point here. And then lastly, trying to pick a color that would stand out, this dark blue. So if we look at this point 2, 4, it moved to the right 3, got twice as tall, that made it 8 tall, and then we moved up 4. So each of these points corresponds to a new point on the graph. So in ALEX, they may give you a whole big graph that goes on forever, and it's kind of hard to tell what happened to that graph. Did it get skinnier or taller? It's hard to tell if something is skinnier or taller when you have the whole thing, so you have to look at the transformations. If you just do these 5 points, in between here and here, the purple and the blue, is 4, it's 4 wide. Here, the purple and the blue is 4 wide, which means this didn't get skinnier, it got taller. So again, how could you see that? Look at how tall this graph is. From the lowest point to the highest point is 4 tall. Here, from the lowest point to the highest point is 8 tall. So it's definitely got taller, and it moved to the right 3 and up 4. So not every question that you complete will be as difficult as finding every single coordinate and applying math to change the coordinates to make the transformation. So here is an example of one which I would say is a little bit easier. So we're going to take the graph in part A, which happens to be the graph of y equals absolute value of x, and we're going to translate it into the graph of y equals absolute value of x minus 1. So I want you to pause this video and think about what that transformation will be. So if you've thought about it, the transformation will be 1 unit to the right. So to do this in ALEX, I'm going to take the picture and I'm just going to translate it 1 unit to the right. So I took my mouse, and you see it's got the hand here, which is automatic in ALEX. I click on the picture, and then I can move it anywhere I want. without changing the tall, short, fat, skinny, and I'm just going to move it 1 unit to the right. Now let's try part B. So they give you the graph of absolute value of x. We want to translate it into the graph of absolute value of x plus 3. So now pause the video and think about what transformation that will be. Up, down, left, right, tall, short, fat, skinny. So if you've thought about it, your transformation is going to be up 3. So this 3 is outside of the absolute value, so it affects the y. So I'm going to click on my picture and I'm going to move it up 3. Now if I move it left or right, that's wrong. You want to make sure it just went only one translation, up 3. Okay, let's try this one. So they've given me the graph of absolute value of x, and we want to transform it or translate it to make the graph of y equals absolute value of x minus 4, and then subtract 2. So remember, inside the bars is what's happening to x, outside the bars is what's happening to y. Here I see x minus 4, so pause the video and think about what transformation that would be. You might need to write it down. You might be able to think it. So we know that the absolute value of x minus 4 takes the graph of absolute value of x and moves it to the right 4. So that's going to be my first translation. So I use my mouse to click on the graph and I move it to the right 4. Now I have to think about what happens with that subtract 2, which is outside the absolute value bars. So again, pause the video, think about what that means and what should happen to your graph. If you're going to make the coordinates, make the coordinates. Now, what happened to that graph? Well, minus 2 is outside, so it's a y stuff, and we're going to go down 2. So I'm going to click on my graph that I've already moved to the right 4, and now I'm going to move it down 2. So now one last example in ALEKS. Here they've given me the picture which does not correspond to any function that we have from our parent functions, and we're going to transform these graphs. So here's the graph of f of x, and we want to graph y equals 2 times f of x. So we have to think about where that 2 is and what it's going to do to the graph. So I'll let you think about it by pausing the video, and then when you're ready, press start. That 2 is outside of the f notation, which means I'm timesing the y values by 2. Now, how am I going to do that? I'm going to start with my pencil function here, my pencil button, so I can graph that. So now this point is over here at -2, -2. And what I'm going to do is I'm going to make the y's twice as tall. So if this y value is -2, and I multiply -2 by 2, I would get -4. So I'm not moving left or right, I'm just changing the y value to -4, and that will make a point. Now this other location here, this other extreme, is 2, -4. So if I times that y value, -4 by 2, I'll get -8. So I will then put this down at -8. Now, that's not my answer. Now I need to connect it with a line. The reason I put those points is to make it easier for me to plot my line accurately. So I'm going to hit the segment button, and it tells me to place the first point, so I'll place it here. And then it tells me to place the second point, and I'll place it here. So this became 2 times as tall. Now, since it was negative, it's tall in the downward direction. Stretched, but it's still twice as tall. If you see, this original graph was too high, right? The lowest it was -4, the highest was -2, so it was too high. Here, the lowest is -8 and the highest is -4, so it's 4 tall, so it's twice as tall. But it didn't get any wider. Now in this second one, they've got a little bit more complicated picture, and what we're going to do is we're going to do the same idea. Moving the points without necessarily writing down the math. So I want to graph y equals g of 2x. So think about where is that 2 located and what is it going to do to the picture. Pause the video and think about it. You either write it down, maybe you need to do the coordinates like we did in class. So that 2 is in with the x. So if I was solving 2x equals a number, to solve for x, I would divide by 2. So this means that my x values are going to be half as large. Now, x values is left and right. So I'm going to go ahead and take my pencil and I'm going to think about the extremes. So this point right here is -2, 4. So if I half the x part, that -2, it'll become -1. So -1, 4 that's where that point is transformed to. So now this middle point, you always do like the turning point. So here there's a point at 0, 0. If I take the x part of that point, which is 0, and I divide it by 2, I still have 0. So 0, 0 is still a point. So I'll click it. And then here, 4, 2, the x value is 4. So if I do half of that, I will have 2. So that point gets transformed to here. Now I'm going to take my line segment button and I'm going to connect those points as they're connected in the original picture. So I connect this first point down to the vertex here. Vertex is just like the apex, where they connect. And then I will start here at 0, 0 and I'll connect. You don't want to make a third line making a triangle because your original picture did not have a triangle.